Yeah, as of now, we have around 60 participants. Anyway, we'll start the session. The remaining will join simultaneously. Okay, so good evening to all distinguished professors, faculty members, research scholars, and my dear students and mathematics enthusiasts. So I'm warmly welcome you all to the second day of our national level online workshop on mastering graph theory with advanced computational tools. So it's organized by Indian
বাবা
Mathematics
তোমার ফোন থেকে আমি নেট নিয়েছি, তুমি অফ করে দেবে না বলো তো।
Indian Mathematics Professors Association and Infinity Research and Development Institute. First of all, I would like to express my sincere gratitude to all the participants for their enthusiastic participation and active engagement during the yesterday session. Your questions and interactions and the eagerness to learn made the sessions highly successful, and my team is very happy for your uh, activeness. So yesterday, we explore the fundamental concepts of graph theory, that is graph representation, graph construction techniques, and the important basic concepts in Python. So we also discussed how graph theory has evolved from a theoretical discipline into a powerful tool for solving the real world problems in network science. So today, we take the next step in our journey. The focus of the today's session is we elevate the fundamental concepts to an advanced graph theoretical aspects. Okay, so they help us to analyze, optimize, and solve a complex network problems and efficiently. During the today's session, participants will gain practical exposure to graph constructions and visualization using Python. Okay, so that is a NetworkX library for graph analysis. Okay, so and also we had seen adjacency, the matrix related concepts. Also, we'll see the some parameters like domination, coloring, it's like that. Today we'll explore in the today's session. So by end of the today's session, participants will be able to model graphs computationally to implement the fundamental graph algorithms. Okay, so as always, I encourage all the participants to actively participate, ask questions. This is a purely hands-on session. The objective of this workshop is to be develop a confidence on the participants. Okay, so let us continue our journey from mathematical theory to computational research. So, once again, I thank you, each one of you, for being a part of this national level learning initiative. I wish you all the participants for inspiring the day two session. Okay, so I think the screen is visible.
No, sorry to share.
Yes, sir.
Okay, so this is our yesterday's notebook. Okay, so just I can open this yesterday's notebook so we can follow. Okay, so just we can recap the few points on the yesterday's session. Okay, so do you have any queries on this day one
அது
session?
பிரச்சனை இல்லை. அதனால மிஸ்டிங்க அதையும் சேர்த்து
Do you have any queries? Yeah, yes, ma'am.
Sir, pip install NetworkX is a step 1 and import packages and import NetworkX as NX is a step 2.
Yeah.
Then run all or run in the separate section, sir.
Ma'am, the For the learning purpose, we have run the cell by cell. Okay.
Okay.
So if you are experienced, there is no need for create a separate skills, separate cells. Okay. So
Okay,
you
okay,
can
sir.
type the single cell and you can run the cell. There is no issue.
Okay, sir.
Yeah.
Okay, sir. Thank you.
Thank you. Is there any other queries? Dear
No.
participants, we request this is a kind request, so don't turn on your mic. Okay, so unless if you have a queries. Okay, so this will be disturbed for all the faculties. Okay, so our team has suggest that. Okay, so we can mute all the participants. Okay, so I request my technical team and Infinity Research and Development Institute. So this is an interactive session. Okay, so if we turn off the mic, okay, so the our outcome will not be satisfied. Okay, so the outcome will not attain. Okay, so please uh, cooperate with us. Okay, so please don't turn on your mic without any queries. Okay, so it's a kind request. Shall we move? Is there any
Yeah.
other queries from the participant side? Okay, I think the chat box. So we'll continue the today's session. As of now, there is no queries received from the participant side. Okay, so we'll continue from. Okay, so yesterday we have created this complete graph. Okay, so it's like that easily we can create any named graph. Okay, so for example, just I can copy this. Okay, so just I can copy this. Okay, suppose if you want to create a cycle. Okay, if you want to create a cycle. Okay, so that is possible. Okay, so for example, just wait. Okay, so I want to create a cycle. Okay, so for example, instead of this complete graph, okay, I want to create, okay, so just we can change instead of a complete, just we can change it as a path. Okay, so this will be create a path graph with 15 vertices. Okay, so that is a very simple. Okay, so just you can, if you can run this. Suppose if you are, yeah. So I expect this. Okay, so I expect this error. Okay, suppose if you are disconnected from the server, okay, so you need to import again as a network X. Okay, so we need to import again. Okay, so just I want to import the network X as an X. Okay, so just I want to import. Okay, so then only this will be execute. Okay, so in otherwise you can move on to the previous. Okay, so you need to run again. Okay, so our notebook is disconnected from the server. Okay, so that's why we can have this type of error. Okay, so now we can execute this. Okay, so this is a path graph with the 15 vertices. Okay, so just I can create the path graph with the 15 vertices. Okay, so it's like that. Easily we can create any type of a graph. Okay, so just wait. I can post this in the chat box. Okay, so this will create a path graph with the 15 vertices. Okay, so kindly execute this. If you have any queries, so please ask your queries. Is this clear? Yeah, if it is clear, please give a thumbs up or mm, the chat box as an S. Okay, so we can move to the next.
सर मैं AI दिखा रहा हूँ.
Yeah, yes. Shall we move? Okay. So the next, suppose if you want to create, we have some other graphs called wheel graph. Okay, so for example, we can create a cycle. Okay, so just instead of a path, just change it as a cycle. Okay, so this is a cycle graph with 15 vertices. Okay, so I want to create cycle with 15 vertices. Okay, so just I have changed only instead of a path, just I have changed it as a cycle. Okay, so that is a very simple. Okay, so just you can execute this. Okay, so this automatically create a cycle with 15 vertices. Okay, that maybe you can change anything. Okay, so for example, if you want to reduce as a 10, okay, so just you can change the values. Okay, so you can execute this. Okay, so this is a cycle with the 10 vertices. Uh, Nisha ma'am, is this? Shall we move? Yeah. Okay, so this is a cycle graph with the 10 vertices. So you can change anything. Okay, so for example, if you want to create a cycle graph with any number of vertices, okay, that is possible. Okay, so just I have changed instead of a path, just I can change it as a cycle. Okay, so that's it. Okay, so this is a cycle graph with 10 vertices. Okay, so and one more we can have suppose if you want to create a already we had seen complete and path cycle. Okay, so suppose if you want to create a wheel, okay, so that is a wheel graph. Okay, so just I can create the wheel graph with the 10 vertices. Okay, this is a wheel graph. Okay, so wheel graph with the 10 vertices. So just we can execute this. Okay, so this is for the wheel graph with the 10 vertices. Okay, so we can reduce the size and we can have a wonderful part. Okay, so for example, just I can create a wheel with 8 vertices. And see, so this how we can easily create any type of a graph. Okay, so we can create any type of a graph with the help of this. Suppose if you don't want the labels, okay, so here we can use the labels, one, two, three, fours like that. Okay, suppose if you don't want the labels, okay, so on the time, easily we can use this. Okay, so for example, here, okay, so in the same, we can use the complete graph with 10 vertices. Okay, suppose if you don't want the vertex label. Okay, so on the time that is very simple. Okay, so we need to use this matplotlib. Okay, so just we need to use this matplotlib is a one another one library. Okay, so this library which will be helpful to yeah, yeah, yes, yes. Varun sir, yeah, that's why we can use the minimum number. Okay, so if you use the wheel with 15 vertices, okay, so within this layout, it's not possible. Okay, so we can, I will explain the later. We can fix the positions like that. Easily we can plot the 15 vertices. Okay, I will explain later. Okay, suppose if you don't want this vertex label. Okay, so on the time we need to use this matplotlib. So this matplotlib is one of the library. This will be helpful for all the mathematician. Okay, so if you want to visualize any concepts, we need to use this library. Okay, so just I want to create this is already we have done. So I want to create a complete graph with 10 vertices. Okay, so this is already we have done. Okay, so nx dot draw. Okay, so my graph name is G. So this is already we have done. So here with labels. Okay, so just I want to put the labels as a false. Okay, this provides. Okay, so this eliminate the edge labels. Okay, so here you can see the 1, 2, 3, 4s are there. If you don't want the edge,
సరిగ్గా జనిత థ్యాంక్ యూ
if you don't want this edge
புரியல
vertex label, okay, easily we can
சரிப்பா
reduce
தேங்க்யூ
this.
சரிப்பா தேங்க்யூப்பா சரி சரி இப்போ போச்சா
Okay, so just I want to use this with the labels are false, and also we can change the node color as a black, and as well as we can change the size. Okay, so if we execute this, you can see the complete graph with the 10 vertices. With Okay, so it's like that. Okay, so for example, we can reduce the size of the graph. So instead of 10, just I can use it as a 7. Okay, so just you can execute this. We can use just like it. Okay, so it's like that. Easily we can use any number of graph. Okay, so it's like that. Okay, so if you want to decrease the size, that is also possible. For example, I want the 200. Okay, so just you can use this. You can get the wonderful graph. Okay, so without labels. Is this clear? Okay, so this is applicable for all the graphs. Okay, so in anywhere, if you don't want the labels, okay, so just we need to use this with labels equal to false. Okay, so defaultly with labels are true. Okay, suppose if you don't want the labels, we need to off the labels with the help of this false. Okay, so just wait, we'll post. Yeah, I have posted in the chat box. Let's try this for the some other graphs. Okay, so for path, cycles like that, just try this. Yeah, we have tried in the yesterday. Okay, so but due to the time constraints, we stopped that. Okay, so I will explain. I will explain how to use this weighted graph. Okay, so just wait. Okay, so the weighted graph is a very simple. Okay, so which is with the similar way, easily we can create the weighted graph. Okay, so here just we can use this code. Okay, so for example, here, okay, so it's like this. We can easily create entire code, the single cell, and you can execute. Okay, so for example, here we have used the libraries, the same cell. Okay, so then here we can use the create an empty graph, that is a nx.graph of. Okay, so here, okay, so this is a weighted edges. Okay, so for example, um this 1 comma 2 is nothing but we can have an edge between vertex 1 and vertex 2. The weight is 5. Okay, so and also we can have a 2 comma 3. Okay, so 2 and 3 we have an edge and the weight is 8. It's like that we can fix the weights. Okay, so then we can use the position. Okay, so position is a circular layout. Okay, so I need a the circular layout. That's why we can use this circular layout. Okay, so then we can have a fix the positions. Okay, so for example, we can give a same line also. So here we can split it for the different lines. Okay, so this is nothing but the previous one we can give in the same line. Okay, so it's like my graph name, the position. Okay, so node color, node size, edge color, and font size, like that. Okay, so this is we can easily fix it. Okay, so this is a single line as we seen in the previous. Okay, so here for the understanding purpose we have put in the lines. Okay, so then we can fix the weight. Okay, so display the edge weight. Okay, so here you can see the edge labels, which is we can get the edge attributes from the weight. Okay, so that is already we have fixed. Okay, and the edge weights we can use this nx star draw. This is a another visualization. Okay, so here we can use the draw underscore network x underscore edge labels. Okay, so I need an edge labels for all the edges. Okay, so that's why we can use this position edge labels. Already we have given the edge label inputs. Just I can call this and the font color. It's like that. Okay, so just if you can execute this, we can see it's like that. Easily we can create an edge labels. Okay. So here the 1 comma 2, the weight is 5, and 2 comma 3, the weight is 8, and 3 comma 4, the weight is 3. Okay. So and 4 comma 5, the weight is 6. Okay. So it's like that. Easily we can create the weighted graph. Okay. So just wait. I will share the code. Yeah. I've shared the code in the chat box. Just try this. Okay, so here we didn't use anything new. Okay, here we didn't use anything new. So this is already we had done in the previous. Okay, so just here we can use this new line. Okay, so for example, nx dot get edge attributes. Okay, so just we can use the edge attributes. Remaining everything is same. We have followed in the previously. Is this clear? Is there any queries from the participant side?
Sir, can we give nodes weight out of the circle?
Yeah, that is possible, ma'am. I will explain. I will explain. The position is nothing but here we give a position is a circular layout. Okay, so I need the graph in the circular layout. Okay, so here we can specify that the position. So I need a graph in the circular layout. In the you can see, so in the output we can have form a circular form. Okay, so this is a circular layout that is called a position. Yeah, what are the layout we can? Yeah, I will explain, ma'am. I will explain. I will explain one by one. Is this clear? Shall we move?
Yes, sir.
Yeah. Okay. So the next we'll move on to positioning the vertex labels. Okay. So how to positioning the vertex labels from inside the circle to outside the circle. Okay. So that is very simple. Okay. So it's like that. Here you can see the same code. Okay. So here I want to shift the labels on the upwards. Okay. So just I can create the position. Okay. So just we can change the position of the vertex. Okay. So for example, here we can use this for loop. Okay. This is little bit difficult for beginners. Okay, so here there is no inbuilt functions are there. Okay, so to positionize the vertex labels. Okay, so it's possible with the help of this for loop. Okay, the remaining everything is same. Okay, so the remaining everything is same. Already we are done. Okay, so I have added only one line. Okay, that is a label position. Okay, so just you can execute this and all the labels can see in the upwards. Sorry, I think we need to change the points. So I think so it's like that. Easily we can change the positions. Okay. Um, So with the help of this for loop, okay, so v comma 0 is nothing but that is the first index. Okay, so the v of 1 is nothing but that is the second index plus 20. Okay, so this is an actual position. Okay, so with the help of this, I want to increase the positioning. Okay, so that's how easily we can change the positions. Is this clear? Yeah, I have posted in the chat box. Just try this. Suppose mm, if you want to use the left or right. Okay, so here that is a very simple way. Okay, so suppose if you want to use the um, suppose if you want to change labels as a left or right, okay, that is also possible. Okay, so here I can explain with this. So this is all the labels are in the upward. Okay, suppose if you want to change the labels in the left or right. Okay, so here it's like that. Okay, so this function which will be helpful to that is a very similar. Okay, so in the previous one, just we can use the vertex labels. Okay, so here we can use the coordinates. Okay, so I want to change the coordinates x plus 0.008. Okay, that is nothing but we can extend the space. Okay, that is a x plus 0.008. That means that that will extend the axis. Okay, so here we can use the y. Okay, so y is nothing but that is a y axis. Okay, you can execute this. You can see it's like that we can have. Okay, suppose if you increase that.
Sir, hello.
Yeah, yes,
Hello.
yes,
Sir, can you please repeat what is pause? POS pause.
yeah. The POS is nothing but that is a position. Okay, so that is a position. Here we can fix anything. Okay, so here I can use the circular layout. Okay, so the circular layout we have fixed. Okay, so on all the graph, I need a circle. Okay, so I can explain the different types of layouts. Okay, so the different types of layout, the most of the time we can use the circular layout. Okay, so in the circular
Okay,
layout, which will be helpful to use the entire thing in the circular format. Okay, so and also we can have a spring layout is there. Okay, so the spring layout that will gives the springer positions. Okay, so and also we can have a shell layout. Okay, so and also in the uncertainty conditions, we can use the random layout. Okay, so and also we can have a spectral layout. Okay, so we can have a many types of layouts are there. Okay, so and one more, I think spiral layout. Okay, so it's like that um, around 15, I think so. Okay, so around 15 types of layouts are there. Okay, so with the help of this 15 types of layout, easily we can use the formats. Okay, so for example, if you change, okay, so I can explain with this graph. Okay, so here we can use this circular layout. Okay, so instead of a circular layout, okay, so I want to change it as a graph layout. Okay, so we can, I think this graph layout that will be very tough one. Okay, so for example, here we can use the spring layout. So spring layout. Okay, so just you can execute this, you can see the output. So that is there is no major change. Okay, so here we can use the cycle. So that's why there is no major changes are there. Okay, suppose we can change some other layout. That is a shell layout is there. This is another type. That is a shell layout. So we can have a different types of layout. Okay. So this will be which will helpful to use the different visualization techniques. Okay. So and also we can have a spiral layout is also there. Suppose your graph is follows the spiral. Okay. So the spiral layout is also there. Okay. So here we have used only in a cycle. Okay. So that's why the layout is not changed. Okay. So this is called as a spiral layout. Okay. So this type of layouts which we have. Okay. I will explain later. Shall we move? Yeah, just wait. I can copy this code. Yeah, I have posted. One more query is received from the participant. How can we make a loop? Yeah, that is very simple, sir. Okay. The previous one. Okay. So for example, just I can create one code. Okay. So just I can create a graph G. Okay. So just G is equal to nx dot graph of. Okay. So then we can create a graph. Okay. So for example, G dot just from. Okay. So in this list, I can add a list of edges. Okay. So for example, here we can create 1 comma 1. Okay. So 1 comma 2 we can create. Okay. So the next I can create the same 1 comma 1. Okay. So then we can create 2 comma 3. Sorry. 2 comma 3. Okay. So then we can create 3 comma 1. Okay. So here we have used the 1 comma 1. Okay. So this is obviously creates a loop. Okay. So just I want to visualize this. Okay. So just we can use this nx dot mm, draw network X of G. Okay. So if you want to visualize this, you can see this loop structure which will be created. Okay, so the 1 comma 1, the loop is created like this. Is this clear? Okay, that is a very simple. We need to give the same coordinates 1 comma 1. Is this clear, Ramesh sir? Shall we move?
Yes, sir. Yes, sir.
Hello.
Yeah, yes, sir.
Sir, what is that? Here it is number mentioned as 014. What it represents, sir? Because we have the previous graph. We have 1, 2, 3, 4, 5, 5 vertices and then 1, 2, 3, 4, 5 edges. But it is mentioned
Where
somewhere.
the previous one, this
Yes,
one
sir.
also?
Yes, sir. Yes, sir.
Yeah, sir. This so here we can change the labels. Okay, so for example, defaultly the labels are inside the circle. inside the vertex. Here we can change the label positions. Okay, suppose if you decrease the size, okay, so that will be align the vertex. So here we can change it as a spiral layout. Suppose if we can change it as a circular layout. Again, we can change it as a circular layout. Here I can see. So these are all the vertex
Okay.
labels.
Okay. Okay. Previously it was hidden somewhere.
Yeah, yeah.
Okay.
So
Okay.
this is for creating a loop.
Okay. Okay. Okay.
But here one thing is not possible. The parallel edges is not possible in Python. Okay, so we can't create the parallel edges. That is one thing here. It's we need to take a note. Here we can't create a parallel edges. Okay, so this it's a undirected graph. Okay, so that's why. So we can't create a parallel edges here. Shall we move? Is there any queries? Okay, so then, yes, sir. Okay, so it's like that. Um, so we can
Excuse
elevate.
me, sir.
Yes, ma'am.
Sir, how can we bring the name of the graph G like that in the diagram itself?
Name
Or
of the
figure 1G?
yeah, just right.
Yes, sir.
Okay, so on the time we need to use this matplotlib package. Okay, so it is a library. Here we can change it as a, for example, here in this title, I want to use the plt dot title. Okay, so I want to title. Okay, so title maybe we can use this.
இதை கூட போட்டுடலாம். இந்த மூணுமே ஃபர்ஸ்ட் ரொம்ப டஃப்பாக இருந்தப்போ ஒரு டைம் கேட்டாங்க. இன்னும் இதில் போர்டு எக்ஸாம்ல
Like that, we can change the titles. Okay, so we can change the positions also. Okay, suppose if we
ட்ரையாங்கிள்ஸ்
want,
தான் கொஞ்சம் டிஃப்ரெண்ட்டாக இருக்கும். அதை மட்டும் கொஞ்சம் நல்லா பார்த்துக்கணும்.
we can change the positions. Okay, so it's like that. Easily we can change the. We can give a title. Okay, so the same way, plt dot caps.
ஓகே, முடிஞ்ச அளவுக்கு பாருங்க. அடுத்த டைம் பார்த்துக்கலாம். ரொம்ப எல்லாத்தையும் பார்க்குறேன்ட்டு எல்லாத்தையும் உட்காந்து இதிலே பார்த்துட்டு இருக்கணும்.
Dear participants, so please mute your mic if you
ஃபர்ஸ்ட்
do.
டைம் ரொம்ப காம்ப்ளிகேட் கேட்க மாட்டாங்க. ஒரு கொஸ்டின் தான் போர்டு எக்ஸாம்ல.
Dear participants, so
பயமா
please
இருக்கும்.
mute your mic if you don't have any queries.
மேக்ஸிமம் என்சிஆர்டில் இருக்கிறது இது
I have a typo. Can use like this. So instead of a caption, we have one more options also there. Okay, text. Okay, so the fixed text is nothing but, so we can create the captions. Listening to, yeah, we missed the positions, I think so. Okay, so just we need to give an x-axis and y-axis value. So for example, initially we can fix 0.5. Okay, so 0.5, 0.5 comma, we can give different positions. Okay, so 0.5 comma minus 0.5. Okay, so it's like that. We can fix anything. Okay, so then we can give the bigger title. Okay, that's why we can have an. So here we can have a caption. Okay, suppose if you want to decrease the space, so if that is possible. Okay, so we can increase the font size and we can increase the value. Okay, so for example, here I can use the 0.5. Instead of 0.5, we can use this 0.05. Okay, so now I think, yeah, it's almost closer. Okay, suppose we can decrease the size 0.2. So it's like that we can decrease the size. Okay, so for example, we can use okay, so we can have like this. Okay, so it's like that we can fix the captions. Okay, so with the help of the fig text. Is this clear, ma'am? I think someone asked the query.
Yes,
Okay,
sir.
okay, so this
Yes,
how we
sir.
can
Thank you,
fix
sir.
the caption.
Yeah, yes. Thank
Yeah,
you, sir.
so directly we can use the caption, but we need to create the doc string. Then only we can use the caption. Okay, so this is a direct method. Easily we can use for any beginners. For the advanced user, we can create one doc string. It's like a caption, and we can use the entire notebook. Okay, so this is an easiest way. I think if we compare to the caption. Shall we move?
Yes, sir.
Yeah. Yeah, Surajit Sagu. Yeah, I'm also waiting to move the algorithms. Okay, so but we need to understand some fundamental concepts. So then only we can move on to the algorithms. Okay, so that's why we can teach the fundamental concepts. So surely we can complete this and we'll move on to the algorithm parts. Surely. Okay, so shall we move? Okay, so if it is clear, easily we can create the different types of graphs. Okay, so for example, I think this is very helpful. Okay, so for the bipartite graph. Okay, so suppose if you want to perform the machine learning process, we need to know this bipartite graph. There is no inbuilt functions to create the bipartite graph. Okay, so we need to create the doc string. So then only we can incorporate the bipartite graph. Okay, so this is a bipartite graph, the doc string, which we have developed by intent. Okay, so just we can create an empty graph. Okay, so I have added the first partite set. Okay, so just we can add it the first partite set, the 1 2 3 4, and this is the second partite set. Okay, so in the bipartite set we can have a two partite set and one edge set. Okay, so then we can create the edge set. Okay, so this is already we have done the previous itself. Now we need to create the bipartite. Okay, so just we can check the NX is a bipartite. Okay, so this means that I want to check the given vertex set, it follows the bipartite. Okay, so if it is bipartite, I can have a true. Suppose if it is not a bipartite, I can have a false. Okay, so then I want to create the positions. Okay, I want to assign the positions. Okay, so for example, what is the top nodes and what is the bottom nodes? Okay, so it's like I can use the for loop here. Okay, so we can assign the node positions. Okay, so then we can use the bipartite graph. Okay, so for example, here we can use the position of the vertex, and also we can update the labels. Okay, so then we can easily print out the colors. Okay, so for example, yeah, I think just wait. The indentation error is nothing but, okay, so we need to fix the indentations. Just wait. So we have an indentation error. Okay, so the indentation error is very simple. Okay, so as a beginners, we can face this type of errors. Okay, I think here I can't found the indentations. Okay, so it's like that. Okay, so just I can remove the indentation. Okay, so with the help of my team. Okay, so here we can use this indentation. Okay, so just I can enter in the next line. Okay, so here we can put the same line, but here we can change into the next line. Okay, so that is a position node is 0 comma I, and this is for the second positional node. Okay, so just we can use the for loop with the help of Python. Okay, so this how easily we can create this. I think this is our partite set one, and this is our partite set two. Okay, so here based on this age, okay, so just we can create this age set. Okay, so based on this age set, so we can connect all the nodes. Okay, so this how easily we can create the partite graph. Okay, so just wait. I can share this. Okay, so this is very simple. If you have any query, so please ask your query. Yeah, I have posted in the chat box. Let's try this. Okay, so just we can use the vertex set, and also we have added the edge set. So then we can give the position of the nodes. This is for the top, and this is for the bottom uh, nodes. Then we can give the positions with the help of for loop. Is this clear? Shall we move? Okay, so it's like that. Easily we can create the tripartite set. Okay, so for example, here we need to use the three vertex set. Okay, so the vertex set 1, vertex set 2, vertex set 3. Okay, so that is very similar. Okay, so we can create the tripartite graph. Okay, so here we can see three vertex sets are added. Okay, so and also we have added an empty graph, and we can fix three for loops. Okay, so for example, the first position, second position, and third positions like that, and also we can update all the nodes. Okay, so this is for the tripartite set. This is a partite set 1, and the green color indicate the partite set 3, and the next one is a partite set 3. Okay, so this we can create the partite set. Okay, so suppose if you want to add the fourth for partite, that is also possible. Okay, so it's like that. Easily we can create the partite sets. Is this clear? Shall we move? Okay, so dear participants, these are all the basic concepts. Okay, so then only we can move on to this next level. I don't know the text size. Yeah, I can post within the two chats. Okay, can post this in the two chats. Okay, so this is first. And in the two chats. Okay, so this is the first chat, and this is the second chat. I've added in the two chats. Okay, so just copy and add in the two chats. Shall we move?
Yes, sir.
So we can have some operations on graphs also there. Okay, uh, it's like a subgraph and also union, and intersection, compositions like that. Okay, so is this needed or we can skip it? Okay, so if you need it, so please put it as a yes for the operations on graphs. So we need to this basic yeah, okay, so we can cover in the quickest way. Okay, so first we need to understand the subgraph. Okay, so in our literature all of them might know what is a subgraph. Okay, so just we can create a graph. Okay, so just we can create a complete graph. Okay, so just we can create a complete graph, then we can easily understand the subgraph concepts. Okay, so for example, just I can create a K5. Okay, so the K5, Okay, so just I can create a K5 is nx dot. Okay, so this is an inbuilt function we can have. So complete graph of 5. Okay, so I want to visualize this and next dot. Okay, so just I can have this complete graph. Okay, so the next I want to create a subgraph. Okay, so our graph name is K5. Okay, so in this K5, I want to make it as a subgraph. Okay, so for example, in this subgraph concept, okay, so we have a direct inbuilt functions there. Okay, so it's for example, in this K5, I want to take it as a K3. Okay, so I want to take it as a K3. Okay, so for example, in K5, okay, so in K5, okay, so K5, this is a K5 is nothing but my graph name. Okay, that may be anything. In the previous one, I can name it as a K5. Okay, so that's why I can use it as a K5 as a graph name. Okay, so this is an inbuilt function subgraph of. Okay, so here we need to fix the vertex. Okay, so for example, here we can choose the vertex like I want to choose the vertex 0, comma 1, comma 2. Okay, so then we can visualize this. Okay, so just I can copy this. Okay, so then we need to display the K3. Just you can check this. This particular vertex, make it as a subgraph. Is this clear for the subgraph concepts? So just wait, I can post this. So this is for actual graph and this is for the subgraph. Yeah, if it is clear, please give a thumbs up. I can understand. Then we move on to the next one because we need to cover many things. So please cooperate with us. If it is clear, please give a thumbs up.
Sir, excuse me, sir.
Yeah, yes, ma'am.
Sir, not only for this complete, for any graph we can have the subgraph, no, sir.
Yeah, in any
Taking the
graph.
vertices.
This is
Okay.
only an example. This is only an
Okay, sir.
example. You can apply for anything. The same syntax.
Yeah. Okay, sir. Thank you.
Yeah. Shall we move?
Yes, sir.
Okay, so the next we can have suppose if you want to perform the spanning subgraph, okay, so that is also possible. Okay, so with the help of uh, spanning subgraph. Okay, so just I can create a graph. Okay, so then we can add the edges and we can plot the graph. Okay, suppose if you want to create spanning subgraph. Okay, so then I can have a code just right. So this is for So this is for the spanning sub. This is my original graph. Okay, so this is for my original graph. Here we have created the spanning subgraph. Okay, so G is nothing but G is our original graph. Here I have created the spanning subgraph concept. Okay, so for example, H is nothing but there is a new graph. Here added the G dot nodes. This is a spanning edges 1, 2, 2, 3, 4, 5. So with the help of this is in one way, and also we can have a this is for our original graph, and this is for the spanning subgraph. Okay, so this is for the spanning subgraph. Okay, so and one more easiest way is also there. Okay, um,
சில சமயம் நிறைய ஸ்டோரேஜ்
Sir,
இருந்தாலும்
is it a spanning tree or spanning subgraph?
this is for the spanning subgraph one. Okay, so we can create
Okay.
anything. Okay, so for example, here we have created the spanning subgraph for this. Think I missed that code. Okay, so if possible, I can share in the later. Okay, so also we can have the yeah, I can found the spanning minimum spanning tree, but I missed the code on the spanning subgraph. Okay, so for example, here we can create a minimum spanning tree. Okay, so the minimum spanning tree of a given graph. I can explain the spanning. This is for the minimum spanning tree. Okay, this is my graph. Okay, so 1, 2, 1, 3, 2, 3, 2, 4, 3, 4, 4, 5. This is my graph. Okay, so in this graph, I want to take it as a minimum spanning tree. Okay, so this is an inbuilt function. So with the help of this inbuilt function, we can get the minimum spanning tree of this graph. Okay, so for example, easily we can visualize this also. I can have a good understand. Okay, so for example, here we can visualize both the graph. We can visualize the G also. So I think both the graph we can have this. So on the time we can use the subplot concept. Okay, so with the help of subplot, easily we can use this. Yes, we can use this PLT dot subplot. Yeah. Okay. So this is our original graph. Okay. So on the left side, here we have created the spanning tree. So with the help of this. Okay. This is a minimum spanning tree. Shall we move? Is there any queries? Okay. So just wait. I'll share the code. Yeah, I think Surajit Sagu. Yeah, that is an induced subgraph. Shall we move?
Yes, sir.
Okay, so I think we have covered um, the subgraph and spanning subgraph. Okay, so the next we can have, suppose if you want to perform the union of a graph, okay, so that is very simple. Okay, so if you have a two graphs, just we can use the union operator. Easily we can create a union of a graph. Okay, that is a very simple one. So that we can skip that. Okay, so just in the previous one already we have the two graphs, already we have plotted k3 and as well as a k5. Okay, so k5 is our complete graph with the 5 vertices. Also we can get the k3 as a subgraph. Okay, so I want to um, mm, compose in the two graphs. Okay, so within the single graph. Okay, so we can use that example here. Okay, so for example, just we can use this compose. Okay, so COM is we can put anything. Okay, so here we can use the COM is a compose of a graph. Okay, so for example, here we can use this nx dot compose. Okay, so this will be gives the composition of the two graphs. Okay, so already we have the two graphs. So one is our K5. Okay, so in the previously we can have a results, So another one is K3. Okay, so in the previous we can have these two graphs. Okay, so here we can use we can plot the graph. Okay, so nx dot. Okay, so just you can execute this. So this is for the composition of the two graphs. Okay, so that is a K5 and K3. Okay, so we can have the composition. Is this clear?
Excuse me, sir.
Yeah, yes, ma'am.
Sir, from the previous one, plot subplot of 1, 2, 1, and then use subplot of 1, 2, 2. What is the difference between the two things, sir?
Here, this is a very simple, ma'am. So here we need to give an indexing. Okay, so this one is nothing but that is a first row. Okay, so here we can have this two is nothing but we can have a two columns. Okay, so then here we can give a position. Okay, so the first position. The second one, in the second one we can have this one is nothing but that is a first row. Here we have a two columns. The second column I need to place this. Yeah. Shall we move?
In this compose, what we are doing, sir?
We need to compose the two graphs, K3 and as well as a K5.
That means both are
We need to
drawn
join.
together.
Yeah, yes, ma'am. Yes, ma'am.
Is it like that? Okay.
Yeah. Okay, so and also we can have the several products of graphs are there. Okay, so for example, in our literature, we have a Cartesian product, we have a tensor product, we have a strong product. Okay, so that is a product graphs. That is also possible. We can easily incorporate on those products into here. Okay, I think we share the code. Okay, so just wait. So this is for K5. Okay. So now we move on to the next product graphs. Okay. So in this product graph, just we can create Yeah, already we have a K3 and S plus a K5. Okay, so just I want to perform the Cartesian product. Okay, so just we can use this cart. Okay, so the cart we can have used as a Cartesian product. Okay, so I want to use this Cartesian product. Okay, so just we can use this nx dot Cartesian product. Okay, so this is a Cartesian product. Now, already we have two graphs, So one is K5. Okay, so one is a K5 and another one is a K3. Okay, so I want to do the Cartesian product of these two graphs. Okay, so then we can easily visualize this nx dot so this is for the Cartesian product of these two graphs. That is already we had defined. One is a K5 and another one is a K3 in the previous week. Okay, so here I think so. This is for K3 and this is for K5. I want to do the Cartesian product of these two graphs. Okay, now. Okay, so for example, here if you execute this, okay, so this is a Cartesian product of the two graphs. Okay, so that is a K5 and as well as a K3. Okay, so this how easily we can create, we can combine any types of products. Is this clear? So this is an example. Okay, you can create any type of a products. Is this clear? Just we perform the Cartesian product of the two graphs. One is a K5 and another one is a K3. Shall we move?
Yes, sir.
Yeah. Okay, so then if you want to perform the tensor product, okay, so just I can copy this. Okay, so this is for the tensor product. Okay, so just I can change the name. Okay, so that is a 10p. Okay, so that is a tensor product. Okay, so here also we need to change it as a 10. This is our graph name. But here instead of a Cartesian, just change it as a tensor. Okay, so just change it as a tensor. Okay, that is a very simple. Okay, so this provides the tensor product of the K5 and K3. Okay, so just have changed the name. Instead of a Cartesian, just I can change it as a tensor. So this is for the tensor product. Is this clear? Shall we move?
Yes, sir.
Yeah. Okay. So then I think we almost cover fundamental concepts. I think we missed one thing. I think what is a random graph? Okay. So how can we create random graphs in Python? Okay. So for example, here we can create yeah. So we need to use one more packages. If you generate the random, we need to use this import sys. This is a one package we have. Okay, so we need to use this package. Okay, so for the creating, if you perform any random, okay, so we need to use this package. Okay, so for example, here we can fix the vertex. Okay, so just I can create the vertex is a 5. So then if you want to give a Q is nothing but our edges. Okay, so I want to create the 20 edges. Okay, so then we can create the um, random graph. Okay, so for example, I can name the graph. Okay, so G is equal to, okay, so just we can use this NX, that is a network X. Okay, so then we can create the that is a GNM. This means the generating the random graph. Okay, so for example, here we can use this inbuilt function random graph. Okay, so then we need to call what is my P and what is my Q. Okay, so that is a very simple. Okay, so this how we can create the random graph. Okay, so now easily we can create this. Okay, so just you can use this. Yeah, I think it's an empty graph. Empty graph. Okay. Okay, so here, so we can use
We have to reduce the number of edges, I think. 5 vertices maximum. 10 edges only will be possible.
this way. We can reduce this error.
Yes.
Okay, so with the help of can use one more for loop. Okay, so for the think six types. Yeah. This way. Think that is randomly choose the values. Yeah, we can use this package also. Okay, so we can use this one more packages. Okay, so we can use this import. Sorry. Can use import. This is and also we can use this import matplotlib. Okay, Oh, and also we can use this. Just wait. I think yeah. It's- Yeah. So this how we can create a random graph. Okay, so this how we can create the random graph. Okay, so for example, here we can fix the what is my P and what is my Q value. Okay, so Q may be value can change any number of vertex or any number of edges. Okay, so but this the random graph will follow the higher order. Okay, so for example, the ceiling value based on the condition of the vertex and based on the edge. Okay, so we can easily create this graph. Okay, so for example, here I want to, this is a clustering concept. Okay, so this is a node 0. We can have a 2 that is assigning uh, degree. Okay, so then this is a clustering value. So all the clustering value we can have a 0. Okay, so this so easily we can create the this that is randomly assigning the degrees. Okay, so with the help of this for loop. Okay, so then we can fix this network X. Is this clear? Shall we move?
Sir, under degree, why are you having 0.000?
Ma'am, here the alignment is changed. Okay, so the degree is nothing but the second column. Second
Okay.
column values. The clustering values are 0.002.
Okay. Right. Sorry.
Shall we move?
Yes, sir.
Sir, if we give the same value again,
Okay,
will
ma'am.
we be getting the same graph or some other random graph?
Some other graph, some other graph. Okay, so suppose if
Okay,
we
sir.
run execute, okay, so we can
Yeah.
change this. Okay, so for example, we can change with the 6. Okay, so we can get the graphics like this.
No, if we give the same value 5, 5 itself,
Okay.
will you get some other graph?
There is no possibilities, ma'am. That's why we can
Oh,
have the same value. Okay, suppose if we increase the size, maybe
okay.
we can have a different values.
Random means randomly generated at the time,
Yeah,
at a time.
the randomly generate.
Okay. So each time if it gives the first same values, it gives same value. Graph means.
No, ma'am. No, if it is a higher graph, okay, so the randomly that will change the layouts.
So if we change the values of P and Q, we will get some other
Yeah.
random graph.
Yes, ma'am. Yes,
Okay.
ma'am.
Yes.
And also we can have the different types of graphs are there. Okay. I think we can skip it. Okay, so next we'll move on to the matrix, the representation of matrix. I think time is 7:36. Okay, so the representation of matrix will see the position. Okay, so here we can have the different types of graphs are there. Okay, so we can explain once again. Okay, so yeah, we can see the Peterson graph. So in this Peterson graph, Dhanalakshmi ma'am.
Yes, sir.
Yeah. So I can explain, ma'am, the Peterson graph. Okay. So this Peterson graph, we need to specify the mm, 10 vertices and 15 edges. Okay. So with the help of we can see the shell layout. Okay. So in the shell layout, I can explain the Peterson graph. Okay, so this is for the Peterson graph. So this is our this is already we have done. Okay, so instead of a graph name, just I can change it as a Peterson graph. Okay, so here we can use the shell layout. Okay, so we have seen the different types of layout. Here we can use the shell layout. Okay, so with the help of this nx.draw. Okay, so this is where already we have done. Here we can split it in the line format. Okay, so we can put the single line itself. Okay, so for the understanding purpose, here I can give the multiple lines. Okay, so here, oh sorry, I think this is a centralized Peterson graph. Okay, suppose uh, here in the cell layout, easily we can fix the inner cycle and as well as outer cycle. That is also possible. Okay, if you create like this, you can get the Peterson graph, exact Peterson graph. Okay, so for example, in the cell layout, just I can create this inner cycle and inner star. Okay, so with the help of the list. Okay, so on the shell layout, is on the shell layout, I can create the n list. Okay, so in this n list, just we can use this. Okay, so this is for the this is for the inner so this is for the outer cycle and this is for the inner cycle. And give in the with the cell. Okay, so this is for the n list. Yeah, list. Okay, so I can explain later. Okay, so I think fix the G, the shell layout. Yes, we can try with this multiple line. So, yeah. This- So I can explain the later. Okay, so the exact Peterson graph, I think
Like here the close brackets red after green. Okay. Okay.
calculate this. Okay, so this is also in the Peterson graph. Okay, so when they randomly change the layouts, that's why we can have the okay, so those we execute multiple times. So you can see. Okay, so I can explain later. Okay, so this is randomly changing the layouts.
Sir, 5, 6, 7, 8, 9 is not in order. Is it not a problem, sir?
Yeah, yes, ma'am. Something happened.
So,
Okay, so I can explain later. Okay, so
okay,
we
okay.
can waste the time. Okay, so in the end of the session, my team is working. Okay, so they can reduce the error and we'll see the concept. Okay, so and also we can have a different types of graphs are there. Okay, so I can explain one by one. Okay, so this is for the 2T graph. Okay, so the 2T graph, this is already available in the literature. Okay, so just we can incorporate in Python. Okay, so this is for the 2T graph of this is for the 2T graph. Sir, in the Peterson graph, there is an error. Okay, so surely I will share in the later. Yes, this is for the 2T graph, and we have the several types of graphs are there. Okay, so for example, this is for the sandwich messy graph. Okay, so just I have changed the name. Okay, so instead of the names, just I can change only the names. Okay, so this is for the sandwich messy graph. Okay, so and so also this is for the tetrahedral graph. Okay, so this is for the tetrahedral graph. Okay, so just I have changed the names. Okay, so this is for the tetrahedral, and so this is for the barbell graph. Suppose if you are using the labeling, okay, so we can use this barbell graceful like that. Okay, so this is for the barbell. This is for the barbell graph of 6, 5. Okay, and we can have this. This is a lollipop graph. Okay, so lollipop graph of 15, 5. Okay, so this is for the lollipop graph of this. Okay, so we can reduce the size also. Okay, so then easily we can visualize. Okay, so this is for the lollipop graph of 5, 10. And this is a Erdas Rene graph. Okay, so this is for the Erdas Rene graph. Okay, so this is an Erdas Rene graph. And so we can have this Watson graph and Parvasi Albert's graph. Okay, so we can have many graph structures are there. Okay. The remaining, I think.
Sir, can we draw octopus graphs?
Octopus graph, ma'am, I can explain tomorrow. Okay, so I don't. I have a syntax, but I want to search. I can explain the tomorrow session.
Okay, sir.
Yeah.
Sir, need a code of Peterson graph.
Sir, that is a error. Okay, so I can share in the later, in the tomorrow session. Our team is working. Okay, so I will share in the Peterson graph later.
Sir, after the Peterson graph, the entire
Okay.
graph will be paste in the chat box.
Ma'am, just we have changed the only names. Okay, so this is an ERDAS Rene graph 15, 0.25. Just I have changed the names. Okay, that's why I didn't share the code. So anyway, I can share. Okay, so this is for ERDAS Rene graph. Because just I have changed the graph name. That is a lollipop. If you want the lollipop graph, just I can change the name as a lollipop.
Hello, sir. Can you please open bipartite graph?
The previous one.
Yes, bipartite.
Yeah, just wait. Okay, so I can show in the end of the session. Okay. I think we paused many codes because I want to search in the previous. So these are the inbuilt function we have. Is this clear? Okay, so I think we almost cover the basic concepts in Python. Okay, so which is similar for the remaining concepts. Okay, so if you understand these concepts here, okay, so easily we can implement these concepts in our lat extra and as well as the remaining parts. Okay, so if you have any queries, so please ask your queries. Otherwise, we can wind up the today's session.
Bipartite graph?
Yeah. I think. So this is a tripartite. This is a bipartite. This one.
Yes, sir. As per definition, that an edge joins every vertex of V1 to every vertex of V2.
Okay.
But there is some 4 is not connected with 6, 5, as you have given the code there.
Yeah. So we can
It is not
give
satisfying the
That
definition,
is
no?
a complete bipartite graph. Every edge is joined with the.
for example, that is no issue. Here we have given the edge list. Okay.
Yes,
So if you
you
add
have
one
given the
more
list.
edge, okay, so for example, here we can add 4,6. That is our wish. Now it's connected. So in the previous, that is a disconnected. Okay, so now we can have this.
Okay. Thank you, sir.
Yeah.
Sir,
Yes, ma'am.
sir, can we have a session for computing various types of matrices for graph, like adjacency matrix, incident
Yeah,
matrix?
yes, ma'am. We planned today. Okay, so that's how we
Okay.
planned today. But almost time is 7:50. Okay, so that is possible to cover. Uh, it's almost we need a 15 minutes time. Okay, so then only we can cover all the matrices concepts. Okay, so that's why we can skip for the today and tomorrow we'll cover. Okay, so tomorrow we'll focus on the algorithm based concepts. Okay, so in the day after tomorrow,
Okay, sir.
we'll see the remaining tools. Okay, which are similar. Okay, so if you know Python, so the which are similar in the remaining tools. I can explain, and also we have our own online platform there. Okay, so I can introduce in the online platform that is reduced these burden. Okay, so no need to use this entire code. Okay, so in the easiest single click way, you can get all the graphs. Okay, so I can explain in the end of the session, surely.
Okay, sir.
Yeah,
Thank you.
thank you. Is this clear? Is there any queries from the participant side?
Sir, a small request, sir.
Yeah, yes, sir.
Sir, yesterday I have joined late, and how to operate this one, sir? Python. Just can you give a
So once
glimpse of?
again, sir,
Hmm.
once again, repeat, sir. I didn't understand your query.
Yesterday I have joined a little bit late, sir, for the session.
Okay, okay, okay.
So initially I missed the how to enter into this Python program. Just can you? Is it possible to share for a few minutes?
Yeah, sure, sir.
Thank you.
Okay, so here we focused on Python. So with the help of Google Colab. Okay, so here we can use this Google Colab.
Okay,
Okay,
sir.
for example, if you open any one of your browser, just type the keyword as a Google Colab.
Okay. Google Colab.
Yeah. So in this tool, just open the first immediate link which are available. Okay, so just open this.
Okay, sir.
And here you can create a new notebook. That's how in this notebook we have worked on the entire code. So that is available in the recording link. Okay, so we have placed the recording link in our WhatsApp group. Okay, you can see the video. You can have an entire guidance.
Okay. Thank you,
Yeah,
sir.
yeah,
Thank you. It's nice. Thank you.
yeah. Thank you, sir. Thank you so much.
Yeah. Thank you very much. Thank you.
Yeah. Is there any other queries?
Is it online or that is this one Google Colab is online, sir?
Yeah, that is a Google product, sir. The Google
Google.
Colab is one of the Google product that is in the
Okay.
free of cost.
Okay.
That is we need a online we need a network.
Mm-hmm.
Okay, so
Okay.
we can work on this.
Okay.
Yeah.
Thank you.
The mobile itself, it is possible. We can run the mobile itself.
Mm-hmm.
Yeah.
Okay. Thank you.
Thank you. Okay, so thank you so much for all the participants who have asked many queries in the today's session. It's really happy. Okay, so my team is happy. Okay, so they work hardly in the today's session we have faced certain errors. Okay, so in the back end, my team is working here. Okay, so he sent the code and I can share that. Okay, so thank you, my team and participants. This is an insightful session. Okay, so we expect your uh, wonderful participation for the remaining days also. Okay, so thank you so much. And also, I would like to thank Infinity Research and Development Institute and Indian
Thank
Mathematics
you, sir.
Professors Association for giving me this great opportunity to interact all the participants in and around India and as well as our participants from abroad. Thank you so much. Yeah, I
Thank you,
think
sir.
Sibaragavi ma'am.
Thank you, sir.
So, yeah. Thank you. This is available in the next 30 days. Because after 30 days, this will be automatically deleted.
Which one, sir? Which one?
The recording link.
Okay.
Yeah.
Okay. Thank you.
Sir, today I practiced with that recording link also because I didn't have the internet connection that was interrupted due to heavy rain in our
Yes,
place.
yes.
So it was very nice, sir.
Thank you, ma'am.
So,
Thank you so much, ma'am.
thank you, sir. Thank you.
Thank you. Thank you for your support and wonderful words.
Sir, I
Yes,
tried
sir. It
Peter
was
Sankara.
really a very nice session. Thank you so
Thank
much.
you. Thank you, ma'am. Thank you.
Sir, I tried Peterson graph. I have posted that code in the chat box, but
Okay, sir.
it got slight changes. Instead of connecting with a star, it has to connect with adjacent, but it got connected with the next adjacent. So I
Yeah,
think
yes,
I have
sir.
to modify one
The
more point here.
previously it have worked, but In the today's session, I can have a error. Okay, so I don't know that. My team also working. Okay, so we can get the exact Peterson graph, but the same code today there
Sorry,
is
I have
no.
posted in that box. Just you try it that you can identify a small error.
Sure, sir. Sure, sir.
Okay, sir.
Sure. Thank you so much, sir. Thank you so much for your support.